December the 25th, Christmas Day, very few people, I suspect, knew what a tsunami was.
All I could see was a wall of water. You know, the sky was blocked.
Coming again!
It was just something out of a science fiction book.
Unfortunately, now, virtually the entire population of this planet knows what a tsunami is and the horror that can strike from a tsunami.
It's a huge catastrophe, most widespread devastation that we've seen from a natural disaster for centuries.
It's like the aftermath of an atomic bomb, is maybe worse.
The tsunami of December 26, 2004, took the lives of at least 250,000 people across more than a dozen countries. It has also energized science to seek a better understanding of these killer waves.
There isn't just one wave, there's usually several waves, and it doesn't follow any particular rules.
The goal? To figure out exactly what happened and what went wrong.
All the critical elements needed for a warning system were missing.
No contact points, no organization, no warning systems.
We were, unfortunately, flying blind.
3 months after the tsunami, what have we learned about this catastrophe? Why did it occur? And will we be better prepared the next time? Wave that shook the world, right now on Nova. It's early morning, December 26, 2004. Southeast Asia awakes to what should be another ordinary day. Fishermen are on the water in Sumatra. In Sri Lanka, 1,500 people take a train along the coast. Among them, a tourist named Shent Ravindra.
I was going to do some scuba diving around the coral sanctuary. My dad was very keen for me to catch the train because of the beautiful scenery that I would encounter on the way down.
In Thailand, Tom Travers and Richard Anthony opened their beachfront restaurant.
I went down, put some laundry in, literally came back, ordered some breakfast through. Yeah, it was just another normal day, basically.
And in Hawaii, scientists at the Pacific Tsunami Warning Center carry out routine tests of their equipment. All these people are unaware they are about to be caught up in one of the worst natural disasters ever. It begins shortly after dawn and without warning when a huge earthquake tears apart the floor of the Indian Ocean. The Earth's crust is divided into giant rafts of rock called tectonic plates. The plates are always on the move. When they collide, enormous amounts of strain build up. Where the plates grind past each other, earthquakes occur. Under the Indian Ocean, one plate is pushing beneath another in a process called subduction. It's been doing this for 40 million years. On December 26th, something snapped.
The Indo-Australian plate is what's called subducting beneath Indonesia. It's sliding beneath the plate that Indonesia is situated on. That interface has what's called stick-slip frictional properties, and that means it drags the upper plate down with it. And it pulls it down and deforms the upper plate, builds up strain energy. Eventually, the stress on that contact exceeds the strength of the contact, and the upper plate snaps back into position.
The earthquake's epicenter is 155 miles from the Indonesian island of Sumatra.
The rupture, the fault that actually tore in the Earth's crust, is about 1,200 kilometers long.
the continental plate shoved out over the oceanic plate by about 10 to 20 meters. Most of the motion was horizontal, but some was vertical because the plate boundary, the fault, is inclined.
Most of the energy travels perpendicular to the strike of the subduction zone. So it more or less went east-west, towards Sri Lanka to the west and towards Thailand to the east.
The earthquake continued for about 4 minutes. Soon after it ended, this seismogram recording the event appeared in California, 8,000 miles away. It will be several hours before analysis will confirm at least a magnitude 9, one of the most violent on record.
For every unit you increase in magnitude, you go up about a factor of 30 in the radiated energy. So it would take 30 magnitude 8 earthquakes to match the energy of a magnitude 9.
In Sumatra, the city of Banda Aceh feels the full force of the earthquake, and buildings collapse. It's more powerful than all the world's earthquakes over the last 5 years put together. Halfway around the world in Hawaii, a few minutes after the earthquake, computers at the Pacific Tsunami Warning Center spring to life as they pick up seismic signals. The Warning Center was founded in 1949 after a tsunami struck Hawaii, devastating the town of Hilo and killing 159 people. Today, the Warning Center operates around the clock, monitoring the Pacific Ocean for tsunamis. In any earthquake over magnitude 6, scientists on duty are automatically paged.
I just fed my cats. I was lying down for a kind of a nap. It had been 3 or 4 days I'd been on duty already. I was on the verge of falling asleep when my pager went off. I looked at the pager very briefly. I could tell from the message that I was dealing with something probably larger than a 6, and I was here within about a minute. And Stu Weinstein was already looking at them.
But I noticed that the trace of this seismogram was very full. It appeared as kind of just like one thick line going across the screen, and that told me that it was a substantial earthquake.
To detect and pinpoint earthquakes, the Warning Center relies on data from a network of seismic stations. But not all earthquakes spawn tsunamis, so they use coastal tide gauges and deep ocean pressure sensors to figure out if one has formed. Located on the ocean floor, these sensors monitor the depth of the water above them. A change could mean a deadly tsunami is passing overhead. Data is relayed to a buoy on the surface, up to a satellite, and down to the Warning Center. There are 6 of these sensors in the Pacific Ocean. This system has saved countless lives, warning countries around the Pacific of killer tsunamis.
Poses a serious threat.
But in the Indian Ocean, there is no such system, and no warning center, although seismic sensors do exist. In the first few minutes after the earthquake, data from these seismic stations alerts Weinstein and Hirschhorn to its location and size, causing them serious concern.
I then estimated the magnitude at a magnitude 8. Our response was, wow, that's a fairly large event. And we issued our first official product, which was a Tsunami Information Bulletin.
The bulletin informs countries around the Pacific Ocean of the earthquake. But not all magnitude 8s form destructive tsunamis. And with no network of tsunami sensors in the Indian Ocean, they do not know if this quake triggered one.
The seismic analysis can only take you so far. We also looked at what water level information might be available, and because this was the wrong ocean, the answer was none.
We had no tide gauges, and so at this point we had no evidence that there was any waves generated.
And this was a tremendous, crippling, frustrating experience, because without water level gauges, we don't know if there's been a tsunami.
We were, unfortunately, flying blind.
As they watched events unfold, their frustration would soon turn to despair. When an earthquake occurs under the ocean, its energy can dissipate as shock waves through the crust or as a tsunami through the water.
Whether that shock wave turns into a tsunami, into a water wave, depends on where in the Earth's crust the earthquake takes place. In this case, it took place very near to the surface of the seabed.
This earthquake was only about 30 kilometres deep, which is very, very shallow. If it had been 200, 300 kilometres down, it would not have generated a tsunami.
As the seafloor lifted, it displaced billions of tons of water above it in a process called tsunami initiation. This released as much energy as 23,000 Hiroshima-sized atom bombs.
As a result of the earthquake, part of the ocean floor has been uplifted and part has been dropped down along the fault surface. Because the seafloor changes, so does the water column above the seafloor. So some parts go up here, some parts go down.
Seconds later, the tsunami undergoes a transformation as the displaced water column splits.
The uplifted area basically collapses and the water rushes away from the uplifted area, creating a tsunami wave that's traveling radially away from the uplifted area. The tsunami wave's now speeding off to some distant shore at 1,000 kilometers per hour.
The main pulse can cover the ocean quite rapidly, which means that in the initial few minutes, the northwest part of Sumatra would have been hit.
In Sumatra, 10 minutes after the earthquake, people are unaware that an enormous wave is charging toward them at over 500 miles an hour. In the open ocean, tsunamis are virtually undetectable. This simulation shows how a boat in deep water is only slightly affected. Fishermen at sea barely notice a tsunami passing under their boat. But as a tsunami nears land, it rears up into a monster, growing by a process called amplification.
As the wave approaches the land, the front of the wave slows down. It slows down to 400, 300, 200 miles an hour. The back of the wave is still going at 500 miles an hour. And the back of the wave catches up with the front, and you get this big build-up of water.
The amplifying wave can have a curious side effect. Before hitting land, it draws water from the leading edge, exposing the seafloor for as much as a mile. This phenomenon would lure thousands to their deaths.
One of the big problems about trying to prevent deaths due to tsunami is trying to stop people rushing down to the beach when the sea goes out. And that happened here. People went down, they saw fish flapping about on the beach, went down to pick them up.
If you see the sea start to go out, you don't stand and wash in awe, you run.
Unlike a classic surfer's wave, tsunamis do not roll toward land. Instead, they surge forward like a flood. The leading face builds into a wall of water. Tsunamis are so deadly because the volume of water that follows is so great.
Tsunami have wavelengths, which is the distance from the crest of one wave to the next wave, of hundreds of kilometres. It will keep coming in maybe for 5 minutes or more, and it has enormous mass behind it.
People see water as being fairly soft, gentle, something fairly benign. But bear in mind that water is very heavy, and a cubic metre of water weighs a tonne. So if you've got one of your kitchen units at home full of water coming towards you or falling on top of you, that's a tonne of water. That's like having a car land on top of you.
The sort of waves that we've seen in the Indian Ocean tsunami of 2004 are probably able to deliver, for every 1.5 metres of coastline, 100,000 tonnes of water, which is an extraordinary figure. And that is coming into the coastline, hitting the coastline with incredible force.
And as the tsunami progresses, as it goes through the coast, it's picking up stones, it's picking up debris, like a tornado almost. And that debris, cars, people being thrown at you at 40 miles an hour, That's going to hurt, that's going to kill you.
Just 15 minutes after the earthquake, northern Sumatra is the first to be hit by the tsunami.
Pemirsa, air dari gelombang pasang tsunami datang. Masyarakat berhamburan menyelamatkan diri. Sebagian besar mereka lari menuju Masjid Baitur Rahman yang berada tidak jauh dari situ.
This street is 3 miles from the sea.
Air yang datang membawa puing-puing bekas gempa.
This is the aftermath of such destructive power. Virtually no footage of the wave hitting Sumatra survives. It was simply too big.
Many of the areas that were totally decimated were devastated by this wave. The cameraman either was very busy running away or unfortunately is no longer with us. So I've no doubt there is plenty of video footage which show a far more destructive wave, which will never be found.
The city of Banda Aceh is in ruins. Even those used to disaster zones have never witnessed anything like it. Few people have seen more destruction than cameraman Jeff Mackley.
I just never thought I'd see anything like this. I've been to more than 30 hurricanes and 35 volcanic eruptions, so sort of thought I'd seen everything that nature could throw up, but it's got nothing on this. This is chaos on an industrial scale. Just unbelievable. You know, all these buildings here and debris up the side of the hill for like 60 metres or about, you know, it's probably 100 feet up the hillside. It's just, it's beyond belief, really.
Mackley's camera shows where vegetation was stripped off the rocks, indicating the height of the wave.
These people now look like ants, and you can see how high up the cliff face the wave went.
With little public education about tsunamis, hardly anyone expected a wave of water to follow the earthquake. In Banda Aceh, even those living far inland were overwhelmed by the onrushing sea.
After earthquake, 20 minutes after earthquake, people see in the sea have water, wave.
And how big? How high?
Yang ketiga ya lebih tinggi. Yang kedua sama, higher than coconut tree.
That's incredible. What was he thinking when he saw this wave?
Waktu kali neum denan kiban nesmiki. Panena demi pikir lom kan lari. After they saw, they seen the wave or to higher, they didn't thinking anything, they ran.
But for most people, there was nowhere to run. The water reached enormous speeds, picking up anything in its path.
The waves will break up buildings, they'll break up cars, they'll carry these things inland. And of course, people will be carried for kilometres along with all this debris and bashing against it and being prevented from actually getting up out of the water by a virtual layer of debris at the top.
Evidence of the tsunami's colossal power litters the coastline.
This is what's left of the Banda Aceh cement works and the wharf area. The ship being totally trashed there. Here we've got these huge big sections of breakwater, and they've just been sheared off and thrown over here like rag dolls. And these pieces here must weigh hundreds of tons. And it just defies belief, really, which kind of gives you some idea of just how awesome this thing was.
The damage to the cement factory is another indication of the height of the wave when it hit.
Just this area we've been walking around here today is like the aftermath of an atomic bomb, is maybe worse.
Under this wreckage lie thousands of bodies. About 3/4 of the tsunami's victims died here in Sumatra. Just a few minutes later, the wave hits the Andaman and Nicobar Islands north of Sumatra. More than 7,000 die or go missing.
For those who have been rescued, a refugee centre has been set up in Port Blair, the tiny capital of these islands. 1,500 were there when we visited, with more arriving all the time. Relatives search desperately for the name of a loved one on the admissions board.
45 minutes after the earthquake, scientists at the Pacific Tsunami Warning Center are still analyzing the data, assuming by now that a local tsunami might have struck northern Sumatra.
This is an evolving story. More and more data is coming in at more and more stations at increasing distances from the earthquake. And now we were dealing with a much larger event. 8.5 is much larger than 8. Stu suggested, that we should really issue a second message on this with some kind of upgrade. Why don't you call Chip? And I said, good idea. We called Chip, and I basically told him the situation.
Now we're getting a magnitude 8.5.
We discussed it and agreed we needed to issue a second bulletin to let people know that this was bigger than we initially estimated, and there was the possibility of the tsunami being generated in the region of the epicenter.
Stu and I crafted a second message and sent it out. We also knew at that point that because of the proximity of the earthquake to Sumatra, that by now they were already inundated.
Southern Thailand, 1 hour after the earthquake. Cities are waking up and beaches beginning to stir. People have no idea a massive tsunami just struck Sumatra and is about to hit them.
Just moving so quick that I bolted.
I was on the roof. I was not going to let the water take me away.
It was just something out of a science fiction book.
Well, one of the extraordinary things about tsunami is that the destructive power, their height, how far they go inland, etc., is hugely determined by the morphology of the coastline. And that is fantastically well demonstrated on the west coast of Phuket Island.
Bill McGuire has been studying natural disasters, including tsunamis, for more than 25 years.
If you look at Bang Tao Beach here, the waves came in like this. This area was almost completely destroyed, whereas in the northern part of the bay here, which is relatively protected, there was less damage.
When tsunamis hit, they can seem like chaotic walls of water, but the damage they cause is anything but random.
If we go further down the coast, we see the same sort of thing again. Kamala here, almost completely obliterated. The headland here as well might have caused some refraction of the wave because they do interact in quite a complex manner. You may get an area which is virtually unaffected, whereas a few kilometres down the coast you may get complete devastation.
Amid the devastation along Thailand's coastline, one bay with a steep underwater slope was virtually untouched by the wave.
Here, where we have Surin Beach, the seabed actually rises quite steeply, and it looks as if that helped to act as a barrier to the tsunami. As in addition, you've got this protective headland here as well. The whole morphology of the seabed and how quickly it rises as it approaches a coast is a critical element in terms of how high the tsunami will be and how quickly and how rapidly and how far it will move inland.
Ian Dick is a lifeguard who helps run a bar on Surin Beach.
This is where the water came to, just over to our restaurant bar here, which is quite amazing. You can see here, the water only came to this depth, whereas on the next beaches, the water went to 7, 8 metres and went a kilometre inland. We've been blessed here, absolutely.
But just a few miles away, Kamala Beach suffered some of the worst damage. Not only was it fully exposed to the tsunami, but the gentle gradient of its seabed amplified the wave's destructive power.
The actual rate of shallowing of the seabed as you approach the coast seems to be quite important in determining the destructive capacity of the tsunami and how far it goes inland. At Kamala, it looks as if the seabed is very, very shallow over a long distance. So there's very little to stop the wave building, to stop it coming in. And the land behind there also is very low-lying, so the waves penetrated kilometres inland in those positions.
In Kamala, Tom Travers and Richard Anthony were having breakfast on the balcony of their restaurant when they saw the tsunami approaching.
I probably went from about 300 metres out to the breakwall here in less than a minute, and then came round sort of under the restaurant, took out the whole beach, went onto the road just a little bit, and then took out our lower deck.
We both looked down, and sure enough, the deck is completely gone. It's not just broken, it's missing. I could just see the entire bay was just littered with umbrellas, beach chairs. For about 150, 200 meters out, everything was just cloudy. And I just thought, wow, something very serious has happened.
Travers began videotaping the damage. 15 minutes after the first wave, just when it seemed like the worst was over, a deadlier second wave struck.
Coming again! Coming again! Big one. Bigger!
Thousands more are caught by surprise.
In any particular earthquake, you'll get a different, what we call tsunami train. There isn't just one wave, there's usually several waves. And it doesn't follow any particular rules. Sometimes the first wave is the biggest one. Sometimes there are maybe 2, 3, or even more relatively small waves, and then you get a huge one in the middle and then some more smaller ones. But normally you do get more than one wave, and they are of different heights, and they arrive over different periods of time, and it can be tens of minutes, even hours, between the first wave and the last wave.
Travers and Anthony continue to film as the second wave engulfs their restaurant.
The first wave came through as like a normal wave in the same sort of direction, and then the second wave seemed to go more towards the sort of our northern end and sort of sweep around the whole bay, and it seemed to pick up momentum as it came round.
Almost out of nowhere, it was like a Class 4, Class 5 rapids just started moving up, like freestanding waves coming right towards us with a bigger wall behind it, and that's when everyone just started screaming, like, run. Couldn't see the road, half the temple was underwater, and just horrendous sounds of crunching and breaking and smashing. It's just horrifying. You're just looking out there going, like, what about the people in town? You know, people are in shops and stores, and it was a really sick feeling, just knowing anybody that would have been on the ground level, gone. I mean, just swept away. Hopefully they floated to higher ground or something, but anybody that was in shops would have been in serious trouble.
After the waves pummel Kamala, the water retreats, sucking everything out to sea.
My God, I hope there's no people in there.
Big disaster. Huge disaster here.
When the water was being drawn out with equal force, I mean, there was cars floating by, the fishing boats were all getting smashed into the trees.
Those lucky enough to survive are left in total confusion.
First first one came through, it was big. The second one came through, and no one thought if there was going to be a third or a fourth. And no one just knew at that stage what was going on. Everyone was in panic.
We were being told to get out of here, to get up into the mountain because there could be a bigger one on the way. And after seeing what the second one did, I mean, it had no mercy.
It's 9 a.m. in Sri Lanka, 2 hours since the tsunami first reached land. On vacation, Shenth Ravindra is crammed onto a train with 1,500 others. Like all of the passengers, he is unaware that he is minutes from one of the worst rail disasters in history.
The train was absolutely packed because it was a Buddhist bank holiday. So, everyone was going back home to see family and also spending time on the resorts. The atmosphere is very different. You get people walking up and down the train offering to sell you tea, sweets and stuff. And also the train has had loads of children. So a lot of noise and very vivid experience.
The train follows the coast of Sri Lanka, about 1,000 miles from the epicenter, and is never far from the ocean.
The train just stopped, and I was a bit frustrated because I thought, oh God, if we're going to be here for a couple of minutes, I just want to get off this train. I heard a lot of screaming and shouting outside, so I sort of peered outside, and I saw what was mainly women running away from the coast, towards inland, and I didn't really know what was going on. At first I thought it might have been like a game of sorts. And then suddenly I realised why they were running. I heard the water, and it just came like this. I didn't see a wave as such, it just sort of came like a flood. Then all of a sudden it came and started hitting the train. And it hit the train to such an extent that the carriage got detached from the other carriages that were behind us and in front of us, and shunted off the tracks. And then the water started to spill in, felt to come all the way up to my chin. And then I thought, right, I've got to get out of here. I was able to climb through this doorway and make my way onto the corner of the roof and the wall. At that moment in time, there was a lot of chaos and pandemonium and worry and screaming. People were using any escape route that they could. People were passing their children through whatever gaps that they could, and I was helping put these children onto the train.
These photos, taken by Ravindra, show the derailed carriages after the wave hit.
I didn't have a clue. I just thought it might have been a freak wave, a one-off. I thought it would have just happened along that part of the coast between Ambalangoda and Hikkaduwa, and it was just a freak tide that came in. People were quite light-hearted about it, thinking, God, that was a bit strange. Lucky we survived. And we're just sort of relaxing and speculating about what happened, and there were kids around me who were hugging me and, just comforting them and making sure they were all right, and we thought that there'd be some helicopters or, some sort of help would be on its way.
But no help is forthcoming. Like thousands along the coasts of Sri Lanka and India, survivors of the first wave cannot imagine that a second, even bigger wave is minutes from impact.
It was a sunny day in Sri Lanka that day. When I saw the second wave coming, I don't know whether it's the way my memory's remembering it, but everything became really grey and, dark and, everything lost its colour. All I could see was a wall of water that took up about 80 to 85% of the horizon, and the sky was blocked. It was limited to about 10 to 15%. I could tell the sort of power of it by the fact that you could see it rippling as it was coming towards us, and the fact that it consumed so much of the houses that were around, gave me a real scale of how big it was. This wave came along, and at this point, there was a lot of children surrounding me. They started clinging onto me and hugging me, and I was losing my balance a little bit on the train. I was expecting that this wave's going to push the carriage to a point where the carriage would just tip over, we'd all fall into the water, and then, whatever would happen would happen. But luckily, it just pushed the carriage quite neatly along to the point where it wedged against a house.
Ravindra jumped from the train onto the roof of the house. He was one of only a handful to survive.
My carriage was completely submerged underwater, and the water level was rising quite rapidly. I looked at the other carriage, which was behind us, that was still on the track. That had been tossed around and swiveled completely 90 degrees, and I could see like people still in the train that were obviously dead.
As the train disappeared beneath the water, it killed nearly everyone on board. Throughout Sri Lanka and India, over 45,000 lives were lost. More than 3.5 hours have passed since the earthquake. At the Pacific Tsunami Warning Center, the horror of the disaster soon becomes apparent as a news report posted on the internet confirms everyone's worst fears, that the earthquake has generated a tsunami. But the damage caused by the tsunami seems too large for the size of the earthquake.
We were shocked at the enormity of the casualties. We thought we were still dealing with a magnitude 8.5. We were all wondering, how can an 8.5 produce this kind of damage?
An email from a special seismic analysis station at Harvard explains what they are seeing. The earthquake is an 8.9, 4 times larger than an 8.5.
At that point, things started making sense. Then we started to figure out who can we contact that's ahead of the wave.
No contact points, no organization, no warning systems that I know of in the area. Picking up the phone and thumbing through the phone book or thumbing through the web is useless. In fact, it could be dangerous because you're not concentrating on warning someone who can actually do something for the people. So we're brainstorming, basically. Who can we call?
We then created a tsunami travel time map for the Indian Ocean basin. This gave us an idea of how much time we had in order to warn people. It told us where the wave was presently, and then immediately we started to try to contact nations that were ahead of the wave.
Less than 4 hours since the earthquake, the Maldives are next in the tsunami's path of destruction. With the wave charging across the ocean at the speed of a passenger jet, it seems like a losing battle. But using their travel time map, scientists at the warning center realize there's still time to alert Africa.
We contacted our State Department and we advised them that this was a very large earthquake and there was the possibility of tsunami waves striking the east coast of Africa.
The State Department Office of Operations immediately patched us through to the embassies in Madagascar and Mauritius, and we gave them a warning.
Their embassies in East Africa would also contact people in positions of authority to try to get out some sort of warning to the East Africa coast.
The news reaches Kenya with enough time for people to evacuate the coast. There is only one fatality.
I've heard reports that some warning filtered out there, and if we were the genesis of those warnings, that would make us happy.
The tsunami dissipates as it progresses beyond the Indian Ocean. Over the next 24 hours, disturbances are detected in all the world's oceans. For most, the tsunami of 2004 was totally unexpected. But this was not the first one to hit Southeast Asia. In 1883, the volcanic island of Krakatoa was blown apart, triggering tsunamis that proved catastrophic for Java, Sumatra, and the surrounding islands. Like Krakatoa, the 2004 earthquake was one of the most violent geological events on record. Though there's debate about whether the earthquake was a 9.0 or a 9.3, it was at least the 5th largest in history. So big it shifted the entire planet.
The force of the earthquake has caused the Earth to wobble.
Richard Gross of NASA's Jet Propulsion Lab used seismic data to make some startling calculations.
The earthquake has caused the mass of the Earth to be out of balance, which has caused the Earth to wobble by about 2.5 centimeters. This is just like the tire on your automobile. If your tire is not balanced, it will not spin smoothly.
The violence of the earthquake also shortened the day by making the planet spin faster.
This is just like a spinning ice skater moving her arms closer to her body. As she moves her arms closer, she spins faster. As the mass of the subducting plate moved down closer to the center of the Earth spins a bit faster, making the length of the day a bit shorter by about 3/millionths of a second.
The size of the earthquake shocked us. Probably the largest earthquake in 40 years. Since any of us have been working in this field, and since the advent of modern seismographs. So we were all shocked, and we were witnessing the largest earthquake on modern record.
But was the 2004 earthquake just a freak event? As Krakatoa showed, the region has a history of catastrophic geological activity and tsunamis.
We started this work a little over a year ago and tried to look at the wider perspective and what other hazards might be presented in the entire Indian Ocean. And then I realized that these massive earthquakes do occur off Sumatra that are so large that they could cause tsunami that might affect the entire Indian Ocean basin. In 1833, a massive earthquake occurred off Java, and we know that the massive tsunami created by the displaced water wiped out whole villages along the coast of Sumatra. The 1883 eruption of Krakatoa did cause a massive tsunami. The primary area that was affected by that was Indonesia. In 1977, a very large earthquake, magnitude 7.8, occurred just offshore the island of Sumbawa. And this earthquake was responsible for the largest tsunami observation in Australia, which was 6 meters on the northwest Australian coast.
Cummins and other scientists called for a tsunami warning system in the Indian Ocean over a year ago. A warning system like the one in the Pacific might have saved countless lives.
When I first saw the footage of the tsunami inundation, I found it depressing and I found it frustrating.
There was no sea level data, there were no designated contact points in any of those countries, there was no tsunami education in place. All the critical elements needed for a warning system were missing in the Indian Ocean.
We knew that if this happened in the Pacific Basin, the loss of life is something certainly we could have prevented. It wouldn't have been anything on that scale.
Most tsunamis occur in the Pacific, but earthquakes are not the only cause of these killer waves.
There are at least 4 causes of tsunami. There are earthquakes, which cause tectonic displacement of the sea floor. There are asteroids, which are thought to have caused very massive tsunami but are very infrequent. There are also volcanic eruptions, which can lead to landslides, and an explosive eruption beneath the seafloor would cause a tsunami. There are also spontaneous landslides, either that occur above the water and insert mass into the water column, or underneath the ocean that change the shape of the ocean floor. But if you're actually going to take concrete steps towards mitigating these kind of hazards, you really have to do some kind of risk analysis and decide where the risk is greatest, and so you can concentrate resources there.
It's estimated that tsunamis pose some degree of risk to almost a quarter of the world's population. A number of scientists fear that in the Canary Islands, off the west coast of Africa, 120 cubic miles of the Cumbre Vieja volcano could collapse into the Atlantic Ocean, creating an enormous tsunami.
That may generate waves 100 metres high in the Canary Islands themselves and maybe 7 to 10 metres on the south coast of the UK, and waves that are 20 metres high all down the eastern coast of the US. When they hit the eastern coast of the United States, they're estimated to expend the same energy for every 100 metres of coastline as was generated by the collapse of the Twin Towers, and that's for thousands of kilometres all the way down the east coast.
Scientists disagree over the likelihood of this scenario. But there's virtually no disagreement about the risk of a tsunami hitting the west coast of North America.
The risk in the Pacific Northwest is severe, really. There's really no difference at all between the Pacific Northwest and Sumatra.
Like Sumatra, two tectonic plates converge just off the coast of Oregon and Washington in a place known as the Cascadia Subduction Zone. And many think it's not a matter of if an earthquake will cause a tsunami here, but when.
What we're looking at is a computer model of the Oregon continental margin. So here's the coastline, the Cascade Mountains in the background, and what we're looking at right here is the plate boundary between North America and the Juan de Fuca Plate. And we see strong parallels between the detailed structures in Sumatra and in Cascadia.
Just like in Sumatra, one plate is diving under another in Cascadia, building up huge amounts of strain that are released in massive earthquakes. Geologists have discovered that 19 large earthquakes occurred in the last 10,000 years along this fault, an average of one about every 500 years. The last one was 300 years ago.
So we're now essentially in the same position Sumatra was in on Christmas Day, where we know there's a subduction zone there. We know how long it was since the last one. We know quite a bit about all the previous events going back 10,000 years. The one thing we don't know is what day is the next event going to happen.
So is there anything we can do to protect ourselves against these deadly forces of nature? No place on Earth has experienced more tsunamis than this building at Oregon State University. Inside is a wave tank half the size of a football field, the largest in the world, devoted just to tsunami research.
Compared to most natural disasters, we know a lot less about tsunamis, just because they're so rare and they're so unpredictable. And there's really, practically speaking, no way for us to stop it, but we can certainly prepare for it and plan better. And that's the nature of the work that's being done here.
This is a scaled-down model of a coastal city, complete with buildings and cars. The scientists will inundate this city with a tsunami and study its effects.
One of the questions during the inundation scenario is what happens when this wave comes through. What are, for example, some of the largest forces that the buildings would experience so we can better design foundations? And then also what happens to debris, so when the wave hits things like cars and other smaller objects, how they would be moved.
Instead of an earthquake, a machine called the Wave Maker generates tsunamis here.
Okay, Shen, you want to run a wave?
Stand by. Go.
Typically for an experiment, what we'll do is instrument it with gauges to measure the height of the wave, the speed, and then also the force or the pressure of the wave as it hits the buildings.
The experiments will provide valuable information that cannot be obtained when a real tsunami comes along. The information will be scaled up to help identify structures that are most at risk in a tsunami, design buildings and bridges that can withstand the force of the waves, and plan emergency evacuation routes.
The tsunami community is certainly a global one. The data that are collected here in our laboratory will also be used by scientists around the world to help better their areas for preventing tsunami disasters.
The wave tank is just a few years old, so how well it can help predict events in the real world is not yet known. Meanwhile, the United States is adding 32 new buoys to the existing tsunami warning system to increase protection in the Pacific, Atlantic, and Caribbean. And world leaders are calling for a warning system in the Indian Ocean, where there are seismometers, but no tsunami sensors.
We've got to try to help them rebuild and start again and have an early warning system, have systems to mitigate disasters that do occur so fewer people die in the future.
But technology is not the only solution.
One of the big issues about warning is that after you've told people that tsunami is coming, they also have to be educated on what to do and where to go.
To us that have been working on subduction earthquakes for a long time, we see the tsunami warning system as really not just buoys in the ocean, but it's really three parts. It's one part is the buoys in the ocean, one part is educating the people, and the third part is research. But without the other parts, the warning system alone is not really enough to do the job.
Even the most sophisticated warning system would have given northern Sumatra only 15 minutes to alert and evacuate those at risk. But a warning system, combined with public education programs, would have saved many who died in the other countries affected.
In retrospect, the scientific community should have been aware these massive earthquakes do occur off Sumatra, and probably a little more emphasis should have been focused on the Indian Ocean, where it's documented that massive earthquakes occur.
There's a simple choice. We either make a conscious decision and say, although these catastrophes will happen, they may not happen for 100 years or more, we're going to do nothing about them and we're going to accept the consequences. Or we say, all right, they're very infrequent, but we at least need to plan for them so that when this happens, we can save as many lives as possible.
It's been a heartbreaking thing for all of us in the tsunami mitigation community. On reflection, I'm sure every one of us wishes that we had done something in advance to push a tsunami warning system for the Indian Ocean, and that we could have done something to prepare the region for this terrible tragedy. But we hadn't, and the tragedy had unfolded with its devastating consequences that are going to take years and years and years to recover from, and those families may not ever recover.
How well can we prepare for the next big tsunami? Find out on NOVA's companion website for the wave that shook the world.
When a volcanic island was obliterated by an explosion in 1883, a tsunami reportedly sent waves topping 100 feet high. Krakatoa is next.
Educators and other educational institutions can order this or other NOVA programs for $19.95 plus shipping and handling. Call WGBH Boston Video at 1-800-255-9424. NOVA is a production of WGBH Boston.